Hello, my name is Mary Ann. This is Cameron, Michael, Olivia, Dabney, and Chelsea. And our presentation today is on human therapeutic cloning. Human therapeutic cloning is the process in which somatic cells and stem cells are made into human tissue and used to repair damaged and abnormal bodily structure. The genetic material is injected into the somatic or stem cells to create the needed cells. As you can see by this diagram, the cell is extracted from the subject and is then removed of its original genetic material and then injected with the new genetic material of the intended cell. This is then grown and then transplanted into the subject to repair any damage. Since the early 1900s, cloning has been a scientific marvel, but it wasn't until 1990 that the idea of human cloning was sprung up. Unfortunately, due to the Human Fertilization and Embryology Act of 1990, the research of human therapeutic cloning was halted. Thankfully, in 1998, some of the limitations were lifted and research was able to continue, even though it was very limited. Two of the main methods of human therapeutic cloning are somatic cell nuclear transfer and nuclear transferred stem cells. Somatic cell nuclear transfer, or SCNT, is the most commonly used since it is also used in regular cloning. And it has a generally high success rate and usually has minimal complications. Nuclear transferred stem cells, or NTSC, is lesser known, but it's still used, and it has a slightly higher risk of failure, but all of the surviving patients and subjects have been reported to live healthy and normal lives. The ethics of human therapeutic cloning have been argued against since the beginning of cloning, and we hope that soon this will be ended.
Right now, current actions and events of the cloning include a lot of misconceptions about it, such as the process of which stem cells are collected through embryos. Of course, during the process, embryos are destroyed, and many people see this as the destruction of fetuses or potential human life forms. That necessarily is not the case. It's a little more complex than that. Since embryos have no nerve cells, they can feel no pain, and so it's not as immoral as it sounds. And although people do see it that way, there's a lot of uncooperation. People are, for a better term than uncooperation, we don't have a lot of support. There have been a lot of groups who see this as bad and do their best to persuade Congress to pass limitations that prevent us from conducting more research. And however, there was enough research that we do know that potential outcomes can include medical practices, such as repairing tissue damage. We can repair organs, we can possibly cure some diseases through stem cells and through human therapeutic cloning.
Two of the compelling issues about human therapeutic cloning are the chance for the organs that are made through this process to become cancerous throughout their development after a certain number of cell divisions. This is known as tumorigenicity. And this is something that part of our budget will be going towards trying to figure out what causes it and how to fix it. And the other part of our issue is the widespread misconceptions about human therapeutic cloning. The majority of the population, when they hear the words human therapeutic cloning, they will think of reproductive cloning, which is the complete copy of an entire organism. But this is not what this is at all. This is simply taking a blastocyst, which is a group of cells, and extracting the stem cells from it to use to make organs. This is something that we need to make common knowledge so that there are less people against what we are trying to do, because they will understand what it actually is.
Our proposal is to get enough funding to work towards eventually furthering the research on human therapeutic cloning. Some of the funding will go towards eradicating the obstacles preventing further research, and while other funding will go towards the research itself. Our first plan of action is to advertise and educate the media so it will rid the public of rumors and misconceptions about human therapeutic cloning. And when the public is educated, they can make logical opinions based on fact and not propaganda. And once we get the public forth human, we can confront Congress them to repeal limitations and restrictions concerning human therapeutic cloning. And only after the restrictions are repealed can we actually start researching the relations between human therapeutic cloning and cancer.
So for our grant proposal, we decided that we would use our funds in 4 main ways to alert the general public on the common misconceptions of human therapeutic cloning, and to also do research on the tumors that could possibly be appearing in the organs that would be used in human therapeutic cloning. Our first main way to alert the public would be through local television and radio broadcasting, which would be, which is a relatively cheap way to alert all of the public, and is the most common way to reach the largest number of people. Excuse me. Our third way to alert the public would be through a social media campaign through sites such as Twitter, Instagram, and Facebook, and MySpace, and other forms of social media that could get to a large number of people, and to people as of our age as well as adults. And the remaining part of our budget would be focused on cancer research, mostly on the tumors that could possibly go, and to finally get an understanding on how it develops. So for our local television broadcasting, we would give an amount of $15,000 to be used to fund this, and we would also give $15,000 for the local radio broadcasting. Our social media accounts would be free, as we would run them ourselves, and social media accounts cost nothing to run, to sign up for. And for similarities with cancer, such as the tumors, we would limit $100,000 or slightly over, as we haven't used our full funds that we have applied for, to essentially discover the possibilities of cancer and tumors being formed.
Through our funding grant proposal, we plan to make TV and radio broadcasts that will inform the public of the proper use of therapeutic cloning. Once we have a larger amount of approval for our process, we can then start research on the similarity between the cancer cells and the human embryonic stem cells. From there, people will be able to be treated with diseases such as Parkinson's and Huntington's disease, as well as cystic fibrosis, and they will be able to have damaged or dysfunctional organs replaced. As seen here, they can be developed into livers, kidneys, lungs, and other organs within the human body. This process can be saved or improved, but it is not possible without funding. Are there any questions? Many of the limitations it involves the embryonic stem cells, and so it kind of prevents the therapeutic cloning. So in order for the research that we would like to do with the cancer cells, we would have to be able to kind of produce the stem cells from the embryonic stem cells to then have the organs and see about the mutations that can lead to cancer.
And Congress has also passed limitations that forbid us from actually reproducing an actual human being. So part of our research, we would actually like to reproduce a human being. However, Congress, jumping over. I'm sorry, stumbling a little bit. Congress does not want us to reproduce a human being. However, we would like to conduct research on that, actually clone a human being, and just do research.
Yes.
Do you see your group merging well with Group 4 that had the organ production with the 3D bioprinter?
I think that's something that could possibly be done. They both treat the same things and have the same goals, but they kind of go about it in different ways. This doesn't really print the new organ. It uses the embryonic stem cells and then gives it different hormones that can, and like cell markers that make it differentiate into a certain organ within the human body. Yes, in the back.
You mentioned cystic fibrosis. How would this be used to treat?
I'm not fully sure of the process, but I know that it would go through and whatever cystic fibrosis within the human body attacks, it could then help the damaged cells within the human body.
It would deal with rebuilding the nerve cells that have been damaged through the cystic fibrosis and then transplanting them back into the part of the body where they were affected.